this lesson, we'll be discussing functions. By the end of the lesson, you should be able to identify functions from a set of ordered pairs, tables, mappings, and graphs. So a function is when the output, y, depends on the input, x. So each input is paired with only one output, which means that the x value can only be used once. For example, if I have the equation y equals 2x, and I decide that x is equal to 3, when I plug in 3 for my input, so x is 3, my y output is 6. Every time I put in 3 as my input, I will get 6. So to display a function, we can use a set of ordered pairs. So we can use these ordered pairs. This first example here, 3, 5, 6, 1, 7, 2. Those are ordered pairs, and it is a function because each input has only one output. But this set of ordered pairs, 3, 4, 3, 1, and so not a function because if I input x for 3, I get 4, but then the next time I input x for 3, I get 1. That's not a function. From a table, I have these are my inputs, -1, 5, 0, 3, 1, 4, 2, 7, 3, 4. So I have all different inputs and they have outputs. Over here, see my inputs are 3, 4, 5, 4, 10. So I have the same input 4, and then I have an output of 7, and an input of 4, and an output of 14. So that is not a function. In mapping, I look, each ordered pair is connected with this line. So this ordered pair is -5, -2, -1, -8, 4, 8, and 9, -8. So that is a function. Over here I've got -5 with -8, and I have -5 with -2. One input with two different outputs. That is not a function. So determine whether each mapping is a function. So looking at my ordered pairs, I have -4, 9, -1, -6, 1, 6, and 3, 11. I don't have any duplicate x values going to different y values. So it's okay that I'm using that y value twice, but I cannot use the x value twice. So each x value only has one y value. Over here, see how 4 goes with 2 and 4 goes with 3, and then 7 with 3 and 8 with 5. So the problem is the 4. So the input 4 has two different outputs. So that is not a function. The ordered pair of 4, 2 and 4, 3. Determine whether each table is a function. So looking down these x values, oh, I see 2 with 6 and 2 with 4. That's the same input of 2 with two different outputs. That is not a function. Over here I've got -3, -2, 3, 4, so no repeating on x, so it is a function. Remember, it doesn't matter y, just x. My input cannot have two different outputs. Determine whether each set of ordered pairs is a function. So I'm looking at my x values, -2, 2, 8, 3, 7. X is not repeated, so it is a function. Over here I have 4, 3, -2, 4. So I've got 4 twice, and 1 when I have an input of 4, I have an output of 6, and 1 has an input of 4 and an output of 7. So no, that is not a function. So let's see if we can determine which of these are functions and which are not. So this one is a function because I have no repeats in my x values. This one is not a function because 1 is with 1 and 1 is with 3. This is a function, no repeat on my x values. This one is not a function because I got 4 going with 11 and 4 going with 12. This one is a function, no repeat on my x values. And this one is not a function because I've got 1 going with 1 and 1 going with 2. So the x value is the same in two ordered pairs. If the x value is the same in two ordered pairs, it is not a function. The y value is the same in two ordered pairs. Y is okay. That is still a function.